is on innate and adaptive immunity. And I'm sure you've been provided with the introduction to immune system. And somebody has told you that the immune system is divided into two. There is innate immune mechanisms and adaptive immune mechanisms. That should have come during the introduction. You should also have been told that when you talk about immunity, you are talking about the capability of your body to resist harmful pathogens or microorganisms. And this doesn't necessarily have to be the viruses, bacteria, and all that. There are others which you have to resist. Now, for you to be able to resist the pathogens and any other particles which can cause damage to the host or to the human being or to the animals, then they evolved mechanisms which provides protection. Those mechanisms are what we call immune mechanisms, both innate and adaptive. Now, you should also have been told that there are two forms of adaptive. One which uses the different components which are in blood, the humoral immunity. More often than this arm of the immune system deals with the extracellular pathogens. Then there is the cell-mediated immunity, which deals with the pathogens which are intracellular. Now, you realize both of them are actually going to be critical because even the intracellular pathogens will have to pass through the journey of extracellular for them to go to intracellular. So at one time, the humoral immune mechanisms are going to be important for even the intracellular pathogens. Now, the second thing which you have been told, and I do believe that somebody has run you through this, is the immune system uses different forms of chemicals and cells. Now, within the cells which the immune system uses, they originate from hematopoietic stem cell. Hematopoietic stem cell. Now, these cells have several characteristics. And the two I would want you to remember is, first of all, there is the capacity for self-renewal. So they are able to maintain the number because they can renew themselves. That's capacity number one. Now, the second capacity is they have the capacity to form different cell lines. And once they commit into making different cell lines, they lose the capacity for self-renewal. They lose the capacity for self-renewal. In immunology and hematology, because the cells of the immune system are actually part of what you get taught in hematology. We call them hematopoietic stem cells. That tells you that there are other cells, the other stem cells. So these are the cells which make blood. Now, the two pathways which the hematopoietic stem cells can actually use is one, lymphoid stem cells, which will make the T lymphocytes, natural killer cells, and innate lymphocytes cells. Now, within the myeloid pathway, all the other cells which you know of, like red blood cells, platelets, macrophage, neutrophils, basophils, eosinophils, and monocytes will originate within the myeloid stem cells. So it's important to know that's how the cells originate. And these are the cells which are going to be involved in the immune system. And you run through some of them as we move forward. So within here, please remember the hematopoietic stem cells with the capacity for cell renewal and the capacity to develop in different cell lines. And when they they commit themselves to develop in a different cell lines, they lose the capability for self-renewal. And the two mechanisms which you have to remember is lymphoid stem cells, which leads to T lymphocytes, natural killer cells, and innate lymphocyte cells. Now, within the myeloid, the erythrocytes, the macrophage, monocytes, basophils, eosinophils, and platelets are important for you to know that pathways. Now, we do have some characteristics which are important, that the innate immune system has no memory. Innate immune system has no memory. But that's another estimate. We underestimate the innate immune mechanisms. We are in the process, most possible, thinking that sentences may not be correct, but for now, it has no memory. Both the humoral and cellular immune system have memory. And what does that mean? It means once you get infected, once you encounter a pathogen, the first defense which is going to come to your help is the innate immune mechanisms. These mechanisms have been there from birth. They have been there from birth, from the time you are born. They are not antigen specific. They are not antigen specific. They act the same. Whichever antigen or pathogen comes, they'll behave the same. And because of that, they have not been able to learn the specifics about each antigen. And therefore, if you encounter the same pathogen or antigen, you do not get an enhanced innate immune response. And that's because they lack the memory or recall mechanisms. Now, the components which make innate immune systems, there are many. They are cellular and humoral components. And unfortunately, the innate immune mechanisms works well with adaptive immune mechanisms. So if adaptive immune mechanisms is not there, the innate immune mechanisms are not going to be very efficient, and vice versa, and you learn about that. So these characteristics of innate immune systems are important for you to understand. Now, it's important for you then, if you know about those characteristics, to ask yourself, then what are we talking about when we talk about the component of innate immune systems? And because of time, I'll not run through all what I had actually put in these slides. Now, the first is we all have what we call anatomic barrier. It's the first component. Issues of the skin, the hair, the sebum, the pH, they actually form the anatomic barrier. And when that barrier is broken, then all other mechanisms of the innate immune mechanisms will be called to help in ensuring that pathogen is removed from the host. These mechanisms involve inflammation, they involve complement systems, and they involve the white blood cells, which we have actually come across. So which generally means you have to learn all the cells we spoke about, where they originate from. That's the mast cells, the phagocytic cells, which are technically macrophage, neutrophils, and dendritic cells, the basophils and the eosinophils, and know about these roles, especially with the parasitic infections, the natural killer cells, and the innate lymphoid cells. Innate lymphoid cells, if you're using an old textbook, you are not going to find it in your textbooks. They just entered the immunology the other day. So if you are using an old textbooks and some books from elsewhere, you may not find these within the textbook. Now, it's always good for you to go and ask yourself, where if immunologists say that the anatomic barrier are important, what are they? Now, the issues which you need to go and learn are issues of the skin, the GIT, respiratory airways, nasopharynx, eyes, and blood-brain barrier. Those are actually the anatomic barriers which you encounter. And it is not just the thickness of the skin and how it is organized with the actual cells aging from inside to the outside. And when they age, discrimination occurs, being shed away from the skin with all the bacteria and viruses which are on top. The other things like sweat are important within all the chemicals they actually have. Issues of the sebum, and the way actually the liquid flow from inside to outside, flushing all the bacteria and viruses which may actually be trying to enter the organ, and the organic acids which are actually found in some of the fluids, like the tears and all the tears which are found within the fluid. Within the GIT, the movement, peristalsis movement, is a reason why it occurs actually the way it occurs from inside to outside. The GIT acid, pH, the bile acids, and the enzymes, and all the chemicals which are there, including defensive, are important, including some of the bacteria which inhabit some of the GIT, including Gentaria, have a role to play in ensuring actually that those barriers are not broken. When you talk about the respiratory system, the ciliary and the way they beat from inside and outside, this surfactant which is found there and defensins all becomes actually important. So you should go and important. And some of these have got antibacterial, already proved antibacterial effect, not just the mechanical systems of actually the cilia, what is found there within the mucus and within the liquid. Some of the chemicals found have got antibacterial effect, and some of them have got antiviral effect. So when you go back, because we cannot actually finish all these, please revise these and know what is in any of these things we are talking about. So it is a journey which you have to walk. Now, we'll teach you about, because the second component I mentioned was inflammation. You've noted that if you injure yourself, if you get injury of the toe, more often than not, you get swellings. And the second thing which you find you are swollen is the inguinal lymph nodes. They swell. This actually is an immune response. All this swelling is trying to protect the pathogen from being disseminated into actually the entire body. So a layer will form around that pathogen, causing the swelling. And we'll teach you about inflammation. So inflammation is a mechanism which is important in protecting you from a dissemination of the pathogen or further entry of the pathogen. And it also forms actually an area where the cells like macrophage dendritic cells, histiocytes, Kupffer cells, and mast cells, are going to be able to recognize what pathogen is going to try to invade the immune system. Now, these cells do have sensors, or we can call them receptors. They have sensors. And these sensors are to sense any actually pathogen which may actually be trying to enter. And the way they sense this pathogen, they are specific pathogen-associated molecules. The sensors will recognize. Now, these pathogen-associated molecules are almost the same in multiples of actually pathogens. They are constant, they don't change, but you may find one there and you may find the other one there. Now, within the pattern recognition receptors, or what I'm calling sensors, they are found within the innate immune systems. So the PRRs will recognize pumps, and after that, the cells are mobilized. Now, if it's dead tissue, there are different things the PRR will recognize. They're called actually DAMPs, or damage associated molecular patterns, DAMP, or dead, you may want to call them that. So there's DAMP and PUMP, and both of them are recognized by the PRR. Now, when you go and when you start actually pathology, anatomic pathology, you be taught about the characteristics of inflammation, which is redness, heat, swelling, increased blood circulation or mucus, pain, and actually loss of function. Now, these are just not happening. They are happening because different activities are required to ensure that the inflammation is effective in securing the dissemination of the pathogen. All this is meant towards that. And this will become better taught when we teach you about inflammation, but you'll also come across it when you are being taught about the inflammation in anatomic pathology. The complement system is another system which will actually be taught about, which is just a cascade of many chemicals. And you'll be taught that the complement system can be activated by the pathogens, like bacterial cell wall. It can be activated that. And when that is done, it can trigger the recruitment of inflammatory cells. It can tag the pathogens for destructions, and it can destroy the pathogens, and it can actually neutralize the pathogen through antigen-antibody complex formation. So in short, that's the function of the complement system, which is a topic by itself. Now, when we reach there and we are teaching you about the complement system, you'll be told that there are 3 different complement systems. The classical pathways, which will start when the antibody recognizes the bacteria. The alternatives pathways, or alternative complement system, which is spontaneous, and lectin, which will actually be recognized when lectins bind to manus on bacteria. So when we talk about the complement system in the form of innate immunity, technically we are talking about the alternative pathways and lectin pathways, because the one which is going to depend on antibody is going to require proper recognition of that pathogen by information of the antibodies. So in short, The alternative pathways and electing pathways, which you'll be taught, will actually be part of the innate immune mechanisms. The classical pathway will be part of what we call adaptive immune pathways. Now, the cells, and I'm not going to claim to teach all these cells, but it is important for you to know the cells which make the innate immune mechanisms. And try to see that you can be able to identify each of these cells. Now, each of these cells, which are innate, it belong to the innate, which are natural killer cells, mast cells, and the eosinophils and basophils are important for you to understand. So innate leukocytes, please go learn about them. Then the other characteristics which you're going to understand is part of those cells when they undertake the process of phagocytosis, which will include the macrophage, the neutrophils, and the dendritic cells. So in a nutshell, phagocytosis is being mediated by these cells, and therefore that cells, like mast cells, they also actually are involved with allergic or hypersensitivity reactions, although they belong to the innate. And there is the good and the bad about hypersensitivity reactions or allergy. The other bad is the damage it causes. But the good is also actually involved some level of protections, and we can actually deal with that. So it is important for you to understand and illustrate the process which you need to understand about the cells which are involved in phagocytosis. Technically, the way engulfment occurs and the particles which are going to be involved. So go back there and learn about macrophage. And when you learn about macrophage, please understand that they have differences with the monocytes. That's when they are in circulation, they are moving. Monocytes are actually when they're in blood circulation. And they will enter the tissue, they gain the terminology macrophage. And depending on the tissue they are going to reside in, there will be different terminologies. They will have different terminologies. The second cell, which is important, is neutrophils and dendritic cells. Those are the phagocytic cells. When you go to the basophils and the eosinophils, there are some similarities between these cells, but it is important for you when you go also to microbiology to understand these are going to be important in parasitic infection. In issues of antiviral, removing some of the viruses, infected cells, as well as the tumor. And the innate lymphoid cells are going to behave just like natural killer cells, just like natural killer cells. So in short, those are the cells which are involved within the innate systems. Now, the most important thing about all that is for you to understand that most of those cells are going to be involved in the process of phagocytosis, a Greek terminology which means eat and cell. Now, so in short, you need to understand the cells which do phagocytosis, and I've learned to do that. But the critical one which you need to understand is the process itself. And I usually tell students that if you're smart, you can be able to understand 7 processes. Process number one is recognition of the of the pathogen. Now, how is that recognition going to be? How is that recognition going to be? Remember, I spoke about PRR and PAM, that the cells have got actually the sensors, and they will recognize pathogen-associated patterns, recognize some patterns within the pathogen. And when that recognition occurs, then the phagocytic cell starts forming what is called a membrane around that pathogen. When you go deeper, you realize that they start forming pseudopodia. You find that. So when these protrusions start forming, we call that pseudopodia. But purely, actually, is a pull mechanism. It's a pulling mechanism. Now, at the end of the day, the pathogen will be encircled by that pseudopodia, forming what we call a phagosome, Now, when that phagosome is formed, where now the pathogen has been encircled, then there is a fusion of the phagosome with the lysosome. Now, within the lysosome, there are actually chemicals which are very dangerous for the pathogen, that they're able to cause digestion. Therefore, when lysosome and phagosome fuses, we form what is called phagolysosome. It's number 5, phagolysosome. And thereafter, it's just release of actually digestive enzymes which are able to destroy the pathogen. And when that is destroyed, then they need to come out of the phagocytic cell. The excretion or discharge of the material happens. So that process is important for you to understand. But what it doesn't show you is when you are all actually doing this, when this pathogen has been digested, when it has been digested inside here, some of these particles from the pathogen will be picked by different molecules, and we'll teach you about them, different molecules, and will be displayed on the surface of the cell, And this is what now this cell will also end up becoming an antigen presenting cell, because they pick some of these and present it to another cell. So that will originate from there, and will teach you as we actually move. So phagocytosis has twofold, so two important acts. Not only getting rid of the pathogen, but also creating an area where some of the pathogen are the antigens. Coming from that antigen will be used to present to other important cells. That happens all the time. Now, for the sake of, I'll not deal with all those other issues about different aspects of all that. Now, what I didn't tell you after is phagocytosis is important, but there are other actually chemicals which are involved in innate immunity. They are actually part of the cytokines, which are going to help on recruitment and activation of the cells of the innate immune systems. Now, the cells which actually generate some of these cytokines are going to be macrophage and natural killer cells. The cytokines we are involved with are the cytokines which can activate the cells, the cytokines which can induce inflammations, and the cytokines which have antiviral effect. So three types of cytokines which are important when you actually have innate immune mechanism. To activate the cells, to aid in inflammation, and to have antiviral effect. So you can characterize, ask yourself then, what cytokines are we talking about? We'll be talking about interleukin 12 and interferon 1, tumor necrosis factor, chemokines, interleukin 1, and all that. And all these will be taught when you are teaching you about cytokines. But it is important to know that cytokines are going to be important in innate immunity, in activating the cells, especially macrophage and natural killer cells, in inducing the inflammation and having antiviral effect. Right now, I'm not going to bother you in actually trying to remember what cytokines we are talking about, but those three are important. Now, the final rule of innate immunity is in stimulating the adaptive immune system. And this is going to be in two folds. Remember when I spoke about phagocytosis and the antigen presenting take place. So the activity number one, some of the cells which are going to be in innate immune mechanisms like macrophage, they are actually antigen presenting cells. So they require to pick those antigens and present them to the cells of the adaptive immune system. Now, when that happens, there is the antigen and receptor recognition. But that's how far it goes. The same cell requires to send another signal, so that that cell can actually be able to proceed to the second phase of increasing in number and differentiating into better immune cells. And we'll teach you this in a better details in a different lesson. So in short, what should you get from this? That the innate macrophage, which are part of innate immune mechanisms, as they actually perform the innate immune mechanisms, they are picking the antigens for the presentation to the adaptive immune systems. So antigen presentation will be part of it. So in that way, they are stimulating the adaptive immune system. This second one is in providing the second signal, which requires the adaptive immune system to proliferate and differentiate. Purely is increasing in number and becoming better cells, in short. Now, if we come and ask you, you've said all these things, then what is the function of the innate immune system? And there are 5 of them I would want you to actually remember. One of them is recruiting the cells, immune cells, to the site of infections. So when you get infected, the innate immune system will be very important in ensuring that immune cells are called to the area where the infection is occurring. How do they do that? They do that through the cytokines. Cytokines which will be generated are the ones which are going to be involved in recruitment and in traveling of those cells to the site of infection. The second one is activating the complement system, especially innate and lectin pathways. The third one is they require to identify and remove the substance which is trying to enter. And the fourth one is they require to activate the adaptive immune system through the antigen presentation and providing the second signal, which comes from the innate immune system. And obviously, the final one, which everybody talks about, acting as a physical and chemical barrier to the pathogens. And you went through the physical components as well as some of the chemical barriers which are going to be there. So in short, these are 5 things which you require to recall, to remember, and to work through how that happens. Now, moving forward, so I have now been able to demonstrate to you that there is a link between the innate immune system and the adaptive immune system. And I've been able to demonstrate to you that that linkage is developed by the innate immune cells as well as the functions of antigen presentation. Now, then we need to ask yourself, when we talk about adaptive immune system, what is it? The adaptive immune system is a system which you learn, you gain the experience as you encounter different pathogens. Now, it has actually what we call, therefore, immunological specificity. It is specific for each antigen, and you gain memory. And when you gain memory, when you encounter an antigen, if you encounter the same antigen again, the specific immune mechanisms will be very rapid. Sometimes you may not even notice. And it is very rapid because it retains that memory, and you'll be there if you encounter that pathogen again to aid in elimination of that pathogen. It involves B cells, which act through the antibodies, and it involves the T cells, which act through cell-mediated immune system. Now, the second thing, the final thing which you need to know, that the adaptive immune system is able to recognize the product which comes from the host, the cell, and differentiate that from the one which is non-cell, which comes from outside. That mechanisms of being able to differentiate cell from non-cell, we call that self-tolerance. And when we teach you about the development of B cells and T cells, we will tell you how self-tolerance occurs. Simply that this part of the immune system is taught how not to recognize antigens from cells. So if they originate internally, they are not recognized from cells. Now, so the typical characteristics of adaptive immunity is specificity. Specific for each antigen. Doesn't act the same for different antigens, specific. And it is able to discriminate different molecular entities. So it is not random mechanisms. It is guided by the pathogen which you are going to encounter. The second thing, it adapts. It adapts itself. And that is recognizing cell proteins from non-cell. And when it sees cell, it is not going to act. But when it recognizes non-cell, it will act. Fourth is memory. Is memory, which helps later on which it learns as it continues to aid in rapid eradication of the pathogen. So those 4 are important in adaptive immunity. Now, so this is what happens if you get the first infection and this you can learn from yourself, is you realize that the adaptive immunity will be very slow in response. Why? Because it's trying to assemble all the arsenals which are required for it to be able actually to recognize and effect what is required for the removal of that pathogens. So within that time, the pathogen may proliferate and cause disease and symptoms. But after that time, should you get the second exposure to the same pathogen, the response is very rapid. And the pathogen will be killed. So what you not get disease, neither will you get symptoms. So that's actually the concept of memory. The concept of memory, that's the concept. Now, there is a specific way the adaptive immune mechanisms recognizes the molecules or the pathogens. Now, the B cells, which we said acts through the antibodies, have got a B cell receptor. Have got a B cell receptor. Now, when the B cell receptor, which is a service-bound immunoglobulins, and we teach you that this will be either IgM and IgD, service-bound, not circulating, are able to recognize different patterns within the antigen. When they do that, then the B cells will form specific antibodies for that pathogen. So the B cells act through the production of antibodies through the recognition of B cell receptor. Now the T cell recognizes actually sequences, short peptides, which are recognized by the T cell receptor. The T cell receptor is a different molecule altogether. It's not like the B cell receptor. And it is able only to recognize a peptide or an antigen, let me for now call it antigen, when it's bound to major histocomplex, major histocompatibility complex. So it means major histocompatibility complex is the one which is presenting the antigen to the T cell receptor. So that recognition has to occur. And we'll teach you more how that happens, Now, this doesn't, when that recognition occurs, this T cell then will be actually converted into an activated T cell, which is able to actually do certain things. One of them produce cytokines and chemokines. The other one is actually another arm of the T cells to be turned into cytotoxic T cells, which can go and directly destroy the cells which are bearing these antigens. So in short, the B cell recognizes antigen, and they don't require antigen presenting cells because they have a B cell receptor, because they are directly recognizing. And that recognition is not going to be based on a major histocompatibility antigen. So they are not restricted to that. And they act through actually the antibody. But they are specific and form memory. They form memory. I'll not bother you with this because we don't have that much time. Even that. Now, the antibodies, and we'll teach you this better, is you need to know how then the antibodies are able to eliminate a pathogen. There are 7 characteristics which you need to learn. One of them is neutralizations, that the antibodies will cover all the sites which are able to be recognized by our cells. Antibodies will cover that. When they do that, we call that neutralization. The other one is opsonization, and the third is complement fixations, which actually is activating the complement pathways. Then you can end up making the antigen antibody immune complexes, which will either cause agglutination of that pathogens and sometimes precipitation. And later on, which we may actually be able to immobilize the pathogen. The number 6 mechanisms of the antibodies, when we teach you this, when you're teaching about the antibodies, is antigen-directed cell cytotoxicity, which is technically a function of natural killer cells and actually macrophage. And don't forget the effect of antibodies in hypersensitivity reactions, specifically hypersensitivity reaction type 1, type 2, and type 3. And all these will be taught at a later time, So all these will teach you when you're teaching about antibodies. Because we don't have time. We don't have time about that. Now, the final one is the cell-mediated immunity. Now, 2 things which I'm going to mention. One, there are 2 types of cells which are involved with cell-mediated immunity, which is the second arm of adaptive immune system. The helper T cells, whose function is to generate cytokines, which is going to be important in guiding how the cells are going to move, guiding how the cells are going to actually behave, like expressing receptors so that they can be recognized and activating other cells. Now, so T helper cells. Then there is the CD8 T cells, which actually, when they are activated by these cytokines produced as a result of antigen being recognized, will turn into cytotoxic killer cells or T killer cells, cytotoxic T lymphocytes. These are able to actually remove the cells with the intracellular infections. Now, the way to remember which cells are going to be involved in CMI is all the cells which are nucleated will be involved with actually CMI, will be involved with CMI. So that is what I had to tell you. You will have a couple of minutes for questions. When you ADCC, the proper terminology is antibody-directed cell cytotoxicity. Antibody-directed cell cytotoxicity.